Welcome back to topic 36, properties of logarithms. This is part 3. So lastly, what we're going to address is the change of base formula. So for positive numbers, again, because logarithms deal with positive numbers, A, C, and B, with C not equal to 1 and B not equal to 1, we have the formula log base C of A is the same thing as log base B of A divided by log base B of C. And note here that our log base B is log base 10. So this is a common log. So remember earlier when I mentioned that if you try to plug into a calculator log base of a value other than 10, a positive number other than 10, you will not be able to identify it. Our calculators are automatically set up so we're dealing with log base 10. So here, what we can do is, sometimes we aren't given a log base 10. We're given log base 7, log base 20. We're given different values as our bases. So this is a formula that we can use in order to simplify that on our calculator. So another way that we could write this would be log base 10 of A over log base 10 of C. So basically we're taking our argument here and we're dividing it by the initial given base, which is our C. So if we want to see this in action, let's do our first example here, log base 2 of 3. So if we want to rewrite this, that's as easy as log of 3 divided by log of 2. And again, our bases here are automatically 10. You do not have to write that. I'm just writing it for the notes here so you can remember that. But our bases are automatically 10. So because our bases are 10 here, now we can plug it into the calculator to evaluate. So if we have our log of 3, that gives us 0.4771212547. Okay, so we'll have that. And then log of 2 is 0.3010299957. Okay, so what we can do now, we could also set this up in a fraction if you want to evaluate it in one step on your calculator. So we can do parentheses log of 3, then get some division in there, parentheses log of 2, and that gives us 1.58496250. So just for our notes, I'm going to write, once we plugged in log base 10 of 3, we ended up getting about 477 thousandths. Once we plugged in log base 10 of 2, we got about 301 thousandths. And then when we divided the two, we ended up getting 1 and 585 thousandths. So that is our answer, just simple as that. Now, sometimes we're given something in exponential form and we want to identify what the solution of our exponent would be using logarithms and using the change of base formula. So here we want to identify what the solution of 2 to the x equals 7. So the first hint is to express the solution as a logarithm and evaluate. So if we have 2 to the x equals 7, then that means if we rewrite this in logarithmic form, that's the same thing as x equals log base 2 of 7. So in order to solve for x, on the left side we would get x, and on the right side we would use our change of base formula. So first we rewrite, second we use our change of base formula. So we can use our change of base formula. We get log of 7 divided by log of 2. We can plug that into our calculator and get, so we'll get log of 7 divided by log of 2, and we get 2.807354922. So we'll round to the nearest thousands place, as it said. So we end up getting 2.807 as our answer. And honestly, we can check this by plugging back in. So we would plug this back in for x. So we would get 2 to the 2.807. We can plug that into our calculator. 2 to the 2.807, and we get approximately 7. And there you go. So your homework is Pearson topic 36, properties of logarithms, and thank you for watching.